in the model of the monopolist that we have developed so far, the monopolist takes into account the effect of its actions on the price and therefore affects the prices, but is restricted to charge the same price to everyone for every unit that they purchase. In this unit, we're going to study circumstances or markets in which the consumer can do even better by engaging in what is called price discrimination. And what is price discrimination? So a definition is a situation in which you can charge different prices to different consumers despite identical production costs. So it's a situation in which you discriminate on the charges, on the price to consumers, but it's not because it costs you differently to service them. And to understand this better, let's look at two examples. So one example are senior discounts at the movies, which are very common in Europe and in the United States. Is this price discrimination? The answer is definitely yes. Projecting the movie to a senior citizen or projecting it to a 15-year-old costs the same. So as you will see, the monopolist engages in these kinds of pricing rules because it enhances its profits. Now, what about charging extra to deliver a pizza up the mountain? So suppose you live in a city that has a valley and then it has all of these houses in the mountain, and Pizza Hut charges extra to deliver the pizza up the mountain. Is that an example of price discrimination? The answer is no, because it's tied to an excess production cost of servicing those customers. Now let's look at the basic assumptions of this model of price discrimination. It's going to be a simple one, not the most general one, to keep it tractable. So we're going to assume that there are two types of consumers. There are NR, this is a number, red consumers, and we will denote the inverse demand function by this. And this is, by the way, the inverse demand function for each red consumer. And then there are NB, blue consumers, and we will denote their demand function by this. We assume that there are no resales, and you will see why that is important in a second. And this can be because the good that is served is a service, like watching a movie, so you cannot resell it, or because there are laws against it, or because the monopolist can prevent it. For example, you may be able to prevent the sale of goods in which they really require a warranty or service from you by simply denying warranty or service to goods that have been resold. Now, we assume that the monopolist can perfectly observe type. And what it does is it charges, or it offers, a price schedule. This is a new concept. Pi C of Q to each consumer Q. To each consumer C, sorry. So the idea is that if you're a consumer, you're offered this price schedule, and then your problem becomes to maximize, so this is a consumer problem, over Q, the benefit that you get over Q minus the P of C of Q. In other words, this pi C of Q tells you how much you have to pay if you buy Q units. And the key thing is that this function is indexed by C, so it may be different to different consumers. Now, the monopolist has a cost function that has decreasing returns to scale with no fixed cost or semi-fixed cost. And the key thing is that what is the monopoly problem? The monopolist problem becomes to choose the function that it offers to red consumers, or the price schedule, and to blue consumers to maximize its profits. Of course, given that the consumers are going to react by solving this problem. Notice that this problem looks extremely hard at first sight because you need to maximize over the functions that you're going to offer to the consumers. so that they themselves can react and do the best in order to maximize profits. But if you use a little bit of economic logic, as you will see in the next slide, this actually becomes very easy. This is the key for how to solve the problem, so it's important that you understand it well. The key remark is that the monopolist can extract all consumer benefit at any quantity produced or sold to the consumer Q. And let's see why that is the case. So take any consumer, this is consumer C, and suppose that his or her inverse demand function, let's say, looks like this. And remember, this is equal to the marginal benefit of the consumer. We've developed this in great detail before. Now, suppose that the monopolist wants to target this quantity. It wants the consumer to buy this quantity. So this is desired purchase by the monopolist. What can the monopolist do? So it can do many things, but suppose, for example, that it offers the following schedule to the consumer. The function pi looks like this, then it jumps here to the same level there. So suppose that it offers to consumer C this price schedule. What is the best thing that the consumer can do? This is the best that the consumer can do is exactly to do this. This is the best response by the consumer given the price schedule. Why? Well, notice that at any quantity up to this, the consumer gets zero net benefit. It's because it's paying a total price equal to its total benefit. But if it goes above it, it has to pay a price that exceeds that, so it's never going to be above it. It's indifferent between all of this, so you can pick that one. If this particular approximation bothers you, assume that all of this red line is epsilon below, and we get the same answer. But in economics, to avoid those epsilons, we normally assume that whenever there is an indifferent, we can resolve it in the favor of the modeler. Now, notice that this generates a class of potential pricing rules, each one with a different Q. So here is one, another one could go a little bit lower and then jump all the way up to that intersection and keep going. So we can index this class of pi's, of price schedules, by Q. And the idea is that any of them goes down along the inverse demand function up to Q, and then they jump like this. Now, in the previous board, we have seen that the monopolist can get any consumer to consume any amount that he wants while extracting all of his benefits. This implies that we can rewrite the monopolist problem as follows. Maximize not over functions, but over the quantity that indexes those functions for both red and blue consumers of what? The total revenue that he gets from selling to those consumers, but he's extracting all of the surplus that is equal to this, i.e. the surplus that the consumers get from those sales, minus the total cost of production, which is equal to C of NRQR plus MBQB. Clearly, this is identical to the Pareto optimization problem. In other words, because the consumer can extract all of the surplus, its profit maximization problem becomes the Pareto optimization problem. And not surprisingly, it has the same first order conditions for Pareto optimality, which are NR B prima of R equals to NR C prima, are N B B prima of B equals to NB C prima. That is very, very remarkable. And what is going to be the solution is going to be that the QR that the monopolist is going to choose is just a function of the type that we have seen, that has the every consuming are consuming at the optimum, and the same thing for every blue consumer. So both functions are going to look like this. If this is the inverse demand function of type I, the function is, and this is the quantity optimum for type I, the function is going to look like this at the solution. Now, several properties of the solution are worth emphasizing. First, the allocation is Pareto optimal. You have a monopolist, he couldn't care less in principle about generating Pareto optimal allocations, but because the best he can do is extract all of the surplus, and that leads him to internalize the full well-being of the consumers, he ends up indirectly maximizing efficiency. Second, producer surplus is equal to social surplus, and consumer surplus is equal to 0. Because the producer, the monopolist, extract all of the benefit from the consumers, they get no surplus. Third, the distributional properties of the equilibrium depend on the distribution of firm ownership. So, is in particular, if everybody owns an equal share, then you get a Pareto optimal allocation with very nice distribution allocations. But if the distribution of the shares of the monopolies are really concentrated, then you get very poor distributional properties. And the fourth thing is that the price schedule is not uniquely defined at the optimum. The quantities that the consumers consume are, but not the exact price schedule. And let's see why. So suppose that you have, for example, for the reds, you have that this is a demand function for a typical red consumer, that this is the optimal quantity. We have seen that this function that looks like this maximizes the quantity of the producer, but so does a function that looks like this, and one that looks like this, etc. So the price schedule, especially after the Q star, is not uniquely defined. Now, the model that we have developed up to this point in this lecture is an idealization, because if you think about your experience in the real world, you are not offered price schedules by firms, even by monopolists. You are offered prices and quantity discounts and things like that. So a very natural question is, how is this type of price discrimination implemented in practice? And the big idea that I want you to get out of this is that the perfect price discrimination is not possible, because it requires a lot of information. And it's also approximately illegal. There are many ways in which it breaks laws in many countries. But there are good approximations in practice. And let me give you just one example of many that I could give you. So in the United States, and I think in most of the world these days, when you buy a product in the store, it gets scanned. And in most supermarkets, you get these cards. They track who you are either with these loyalty cards, discount cards, or with your credit card. And basically, the supermarkets build a model of you, of what type of consumer you are. They put you in categories, and then they sell you discounts. They send you these coupons, and they give you Antonio-specific discounts. If you buy this many extra units, by, for example, a can of this size, will give you this discount. If you buy this extra unit, we'll give you a discount of this amount. All of those efforts by consumers, by firms, to target, to offer specific discounts to specific consumers are one of the many ways in which the firms spend a lot of computing power and a lot of data collection trying to approximate this theory of price discrimination that we have seen. An open question that I don't know has been settled yet empirically is, how close do they get? I tell you I don't know the answer today, but I can tell you this, that as more and more data gets collected, unless more and more legal restrictions get imposed, the it's natural to expect that the firms will be able to approximate this solution more and more.